Recorded, so if I say something like, hey Sonny, pay attention, then you know his parents are going to hear that later if they watch the video. Okay. Prime factorization. Good. So prime factorization, it's a multiplication statement. Of prime, underline prime factors. Okay, so that's different than factors. Right? If I say factors of 12, the factors of 12 will be 1 and 12, 2 and 6, 3 and 4, because they all multiply to 12. Is that probably a good way of writing it, though? 1, 12, 2, 6, 3, 4? No, it's horrible. Why is that horrible? It's disgusting. Because it's not in order, right? We like to have order and patterns in math, so we'd probably put it down 1, 2, 3, 4, 6, and 12. Numerical order. Okay, that's different than prime factorization. For the prime factorization of 12, what we can do is just do a different way of dividing. So in grade 5, your teacher is telling you how to divide, and you probably did 2 or 3 different ways. So this is just kind of like a factor ladder or division ladder. So we divide 12 by 2, we get 6. Divide 6 by 2, we get 3. And now we have prime factors on the outside of the ladder, 2, 2, and 3. So 12 equals 2 times 2 times 3. Okay? So that's the prime factorization. Okay? What we do is we write a multiplication statement that multiplies to 12. And that's why I use the equal sign right here, because both sides have a value of 12. Now, last year and the year before, you looked at exponents. And you know 2 times 2 is really long. And that's a lot of writing. You're wasting pencil lead. How can you write that a little bit easier and quicker? Yep. Bingo, 2 squared. Okay? So we're going to use exponents as well. And that's kind of what's going to mess you up a little bit. It's because we're dealing with a lot of skills here, putting them together. Okay? Any questions? So another way that you can do this is with a factor tree. If you get a big number, sometimes that's what you're going to deal with. Now 72 is kind of big. Remember, there is a non-calc section for this. Okay, we'll use small appropriate numbers for that though. 72, what 2 numbers multiply to 72? 6 and 12. Is Sunny right? Good. Oh yeah, by the way, always correct me. I check my work. I make mistakes all the time because I'm thinking 3 steps ahead. At least that's my excuse. So please, if there's could be wrong work up there, let me know. All right. Good. 6. What does that break down into? 2 and 3. What about 12? 4 and 3. Sure. I'll go 3 and 4. Okay. No, are we done yet? Are those all prime? What do you guys think? Yeah, 4, right? Something wrong there. So what we should do is just carry it down one more level, and then you can break the 4 down to 2 and 2. So these here are all prime now. And that's what you got to make sure is that you have prime numbers. So we're going to deal with small numbers, right? Things like 2, 3, 5, 7. What's after 7? What's another prime? 11, and then 13, then 17. Now, like I said, after 7, we won't use them too often, okay? Once in a while, but most of them will be 7 or less, so you can always guess and check. Okay, so how can we write 72? What does that equal? Please write it with exponents. Okay, use exponents. Please write the multiplication statement. Oh yeah, where's my class list? There we go. Time to pick on people. I know exactly what we're going to pick on. Sam, what'd you get?
2 cubed times 3 squared.
2 cubed times 3 squared. How many people got that? Hands up. Awesome. Good, good. Any questions? Questions? No? Okay. Good. So another way of doing the exact same thing is with the factor ladder that we just did. Divide by prime numbers. Make sure that these are prime when you divide. So if it's even, what can you always divide by? 2. Okay. What if it ends in a 0? I say that funny, I know. Or 5. What can you divide by? 5. Good. What if the digits add to a number divisible by 3? Example, 72 gives you 7 plus 2, which equals 9. And this one here, you can divide by 3. So that's a long one, isn't it? You should write that one down. So if that works, then you can divide by 3. So if you can divide the digits sum by 3, you can divide the number by 3. Okay. So what prime number should you start with? Pick one. Alex? Pick a number. 3. Sounds good. So what's 72 divided by 3? I have no idea. Hard number. Thanks, Alex. Well, what's... Pardon? 24? 3 times 2 is 6. 3 times 4. Yeah, good job. Wow, Sonny, you're the man. Wait, what do I divide by next? Pick halfpenny. Sure. 2. We get 12. Next, what should we divide by? Copley. 12 divided by what?
2.
Good. I'm glad you didn't say 6. Why couldn't we pick 6? Because it's not prime. Okay, keep these numbers here prime. What's next? Michael. 6 divided by?
2.
Sounds good. Okay, and the answer is 3. Okay. So now you can see where your numbers are. Okay, don't make sure you finish with a prime number at the very end. Any questions? 2 different methods finding the GCF. Sorry, just prime factors. Okay, we're going to use this a lot. Okay, a lot. It's going to help us. Good. All right. So then again, you can say 72 equals 2 cubed. There's 3 of them. And for the 3's, there's 2 of them. Okay. Okay, 88. Do it yourself. Go. Write the prime factorization of 88. Okay, so I look at 88, and I know it's divisible by 8 and 11, 2, 4, 2, and 2. So then I can carry down my prime factors. So then I rewrite 88 equals 2 cubed times 11. Okay, so the dot is not a decimal. What is it? Yeah, multiplication dot. Okay, usually I make them bigger and raise them up in the middle because they should be in the middle. Okay, so make it obvious. Try not to use X's, right? Get them confused with algebra. How many people got this? Hands up. All right, 120. Go ahead. You guys might have already started. Finish it off, please. Okay, so some of you are doing the factor tree, which is fine. Start getting the habit of the factor ladder. It is a bit better method, especially when you start wanting to look for pairs, okay? So here you have numerical order of the bases, so 2, 3, and a 5. Ignore the exponents. It's the bases that must be numerical order. How many people got this one? Hands up. Any questions? Okay, so now we're going to use this as we get into GCF and LCM. Okay, so GCF stands for the greatest common factor. If you go onto the internet, they might use a different term. They might call it HCF, which is the exact same thing, but the H stands for highest. Okay. And if you go in old textbooks, you might see that too. So just be aware of that. Notice here, factors are smaller than the starting numbers. Okay, we're looking for a number that's smaller than what we have. So I'm going to show you two things. We're going to start with the factors first. So if we have 15, the factors of 15 are 1, 3, 5, 15. Please write the factors of 21 now. Go. What numbers multiply to 21? Try and put in numerical order. You do rough work on the side if you need to. So factors of 21, 1, 3, 7, and 21. So now you can see which one's the highest. It's the 3. So the GCF would be the 3. For some numbers, this is going to be easy to do. If you have really simple, basic, small numbers, this will be quite easy to do. And you're going to do this a lot, especially later in the course. Right now, though, we want to practice some higher numbers. So we're going to look at prime factorization. What we're going to do is divide it slightly different. Okay, we're going to divide both of them at the same time. Okay. The GCF must be in both numbers. So what can we divide both numbers by? 2. Yeah, they're both even. Okay, so this is 26, and this is divide by 2 be 39. Good, thank you. 26 and 39, what is it? What can you divide them both by? Not stuck, aren't you? 13? Perfect. So sometimes you get those weird ones. And so this will be 2, and this will be 3. So the GCF equals 2 times 13. That right here is your GCF. Okay, it's what you can divide both numbers by. Okay, so 52 equals 2 squared times 13. 78 equals 2 times 3 times 13. Okay. Okay. Do you guys see how I'm getting the 2 into 52, but and the 3 into 78? All right. So for the GCF, you want to have the base in both, and pick your lowest exponent. Right. So we have a 13 in both of them. There's a 2 in both of them, but we use the exponent 1. Okay. Most of you are just going to look here and use that method, all right? So let's practice that a little bit. 18 and 24. Divide them both by 2. Go ahead. What can you divide 9 and 12 both by? 3. And so you get 3 and 4. Good. Anything else that's common? Nope. So your GCF is 2 times 3, which equals 6. We should go back here. What's 2 times 13? 26. Okay. So we shouldn't note that. We should go back and see what it is. So I think for GCF, this is a complete answer. You have your factors and you have the final value. Okay. Can't mark it wrong then. Any questions? Okay. Now for 18, that equals 2 times 3 squared. 24 equals 2 cubed times 3. Okay, and that's because 4 is 2 times 2. So you got to be careful here when you're doing this. So if you look in here, we should take out a 2 and we should take out a 3. That's it. Basis has to be in both. Use the lowest exponents. All right. Now this is getting pretty top end. Right, that's pretty top end. Okay. Did I just put any questions? Okay, 72 and 84. Go ahead. Do your factor ladder. Who is the GCF? Anyone? Hepner, what do you think?
U squared times 3.
Which equals? Bingo. I think we got 12. Okay, I'll let you finish. I know I went faster, so I didn't give you that much time. Okay. Any questions? Could you write 72 as prime factorization? Absolutely. 84? Yep, absolutely. Okay. Turn it over. So the LCM, that would be the least common multiple. And least stands for lowest, and often we'll just use lowest because that's more common. All right. Notice that multiples are larger than the starting number. Okay, so we're looking for numbers larger than what we have. So first of all, let's just list the multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 40. Okay, I'm out of space. Pretty tedious, isn't it? Okay. Multiples of 8. 8. Shout out.
16,
Next.
24,
Next. 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 Okay. That's good enough, I think. Multiples of 10. 10. Shout out. Next. 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 Okay. So we did quite a few. Do you guys see the lowest common multiple? 40, 40, 40. Okay. Do you think this method is that fast and easy? You know what? Sometimes it is. You've got small numbers. Absolutely, it's not too bad. Okay. And sometimes you can do this in your head and come up with it really quick. Right? Totally can. Absolutely. So the LCM equals 40. We can also do it using prime factorization, though. Okay, so if we have 10, 15, and 25, please write these numbers on the left side, though, because I'm going to show you a couple things here. What can we divide all three by? 5. So again, we want prime. Good. And we get 2, 3, and 5. So the LCM makes the letter L right here on the outside. Now we have to include the bottom. So the LCM actually equals 2 times 3 times 5 squared. Okay. Go to your calculator. That'd be 6 times 25. 6 quarters, right? 25 cents. 6 quarters, how much? Right, $1.50. So this one without the decimal would be 150. Okay, so sometimes using money can help you do math in your head, just because you're more used to it. Now let's look at the prime factorization of 10. 10 equals 2 times 5. 15 equals 3 times 5. And 25 equals 5 squared. So out of this, what's being included to make the LCM? For the LCM, you use all the bases, right? We have to use a 2, we have to use a 3, we have to use a 5. But did we use 5 to the exponent 4? Right, there's 4 of them. Did we use 5 exponent 4? No, we used 5 squared. So we didn't use 5 exponent 1. Right? For the GCF, we use the lowest. But for this one, use all bases, but use the highest exponent. Okay. So again, understanding that is really top end. Okay. You don't need to be able to do that 100%. It's just a really good idea to try and work on that. This method here, that's the best one right there. If you get that, you'll get your LCM all the time. Okay. So let's try LCM of these three numbers. Sorry, GCF and LCM. So what can we divide all three numbers by? 28, 42, 63. What's 2 plus 8? 30. Can you divide 30 by 3? Yeah, you can divide 30 by 3. What's 4 plus 2? Sorry, 2 plus 8 is 10. I'm an idiot. Okay, so you can't divide by 3. Okay. 42. 63. Can you divide by... Ooh, you can't divide by 2. What about 7? Can you divide by 7? 7 works. Okay, so we don't use 7 a lot. Divide them all by 7, please. Good. Maybe 4, 6, 9. That's all of a sudden easier. Is there a number you can divide them all by now? No. So guess what? GCF stops. Okay? The GCF stops. So your GCF is simply 7 because it goes into all three numbers. Now what we're going to do is carry on to find our LCM. So we can divide them by 2, 2, 3, and this one, the last one, we just carry down. We don't divide it at all. Okay. Is there another number we can divide 2 of them by? Yeah, divide them by 3. The 2 can't be divided, so it carries down. The 3 becomes a 1, and 9 divided by 3 is a 3. Okay. So it's a little bit different, isn't it? So the LCM now, what is it? Please write the LCM out. Two exponent 2, 3 exponent 2 times 7. So this would be 4 times 9 times 7. Ooh, that's a tough one. I'd go to your calculator for that. Okay. Otherwise, just do some multiplication on the side. If I give you something that nasty, 252. Okay. Make sure that you go to prime numbers. Okay. Notice when your GCF stops. Make a line. Okay. This 2 and 3 is not part of your GCF. So you do have to be careful there. Alright. Okay. Try the next one. Go for it. Okay, so GCF would be 2 times 3, which is 6. Okay, then it stops. And the reason why I had to switch pens is because I can't divide them all by this blue 2. So I had to stop my GCF. Now I'm just working on my LCM. I divide here to get 1. The 5 doesn't divide, so it just follows itself down. Just rewrite so I don't lose it. Because if you lose it, that means you're a person that loses. Okay? How many people got this one? This was pretty challenging. So, yeah, close. Okay, good. This one's pretty challenging. Most of you aren't going to be, we're not going to be working with 4 numbers. Okay, well, we will a little bit in our homework, but mostly 2 or 3. Applications. So you're working with fractions. When it says simplify, what you want to do is find your GCF and divide both by the GCF. Okay. I think it's 14. What's 98 divided by 14? We're getting a little short here. 7. Good. So the GCF, if you found it, was 14. So what we're doing is dividing both by 14. Okay. This is 2 and that's 7. So when you're reducing fractions, you're dividing by your GCF. Okay. Here, 5, 12, and 3. So when you're adding and subtracting fractions, what do you have to have? Common denominator. So for this one, you want to find your LCM. Whoops, LCM. So that is your common denominator. You've been doing this a long time. All right. So one for this would be 60. That's your LCM, your lowest common multiple, 5, 12, and 3. Now to get your common denominator, you have to multiply this one by 12. So this is 36. The second one, you have to multiply by 5. So this would be 25. And the last one, you have to multiply by 20. So you need to get 140. Okay. But you need to find the LCM to figure out what the common denominator is. Any questions? So I think I'm going to leave it at that because I don't want to freak too many of you out and go run and change your timetables. So we're not going to do any textbook work. What you're going to work on is this worksheet. You guys should have that, right? The next page. Double check. Is that you can do any method you want, okay? So just scratch this out, okay? You can do any method you want. Oh, the word problems are on there. Crap. Okay, I'll have to show you. Okay, you can just scratch that out too. So any method you want. All right. This last one's going to be a challenging one. We'll talk about that tomorrow. Let's just finish off our notes because I saw that was on there. So what she has 2 pieces of material, and she wants to cut them into equal size squares. So she has a material like this, and another piece that's like that, and what she wants to do is make them into tiny little squares. Okay? She wants them to be equal size. So what we have to do is we have to find a GCF. So we have 1236. 6 and 42. We have to find the GCF. What can we divide all 4 numbers by? Always check 2 first. Are they all even? Good, so it works. Divide by 2. 6, 18, 3, 21. What can we divide them all by now? 3. Okay, 3. We get 2, 6, 1, 7. Can we divide them all by another number? No, we can't now. So the GCF equals 2 times 3, which equals 6. So the square would be 6 by 6. So 6 centimeters, sorry, 6 inches by 6 inches. Okay, it did ask for the dimensions, so you should have both length and width, even though they're the same. Okay. Any questions? Drawing the diagram really helps you for this situation. Now we're stacking pails. One person stacks them 24 at a time, the other one stacks them at 40. So one Jed, good old Jed's working on the farm, he goes 24, another 24, another 24, and he keeps going on. Jethro, he's at 40, and another 40, and another 40. Do you think we're finding a smaller number, like the GCF? No, we're finding a number that's larger, which is the LCM. Okay? So, 24 and 40, go ahead, do your division, find your LCM. So the LCM is 120. That's when the pails will be the same height. Recap, GCF is smaller than the starting number. And the LCM is larger than the starting number. It's like they're opposite of their names, right? But it's the word multiple and factor which helps tell which one is which. So, right now I want you to go to unit outline. I'll go back to this in a second. Go up to your homework. And so what you can do is you can circle this and put down tomorrow. Okay, so we'll do this tomorrow. This here is tonight. Alright, you should get a good start on it in class today right now. Alright, so no textbook work, just the worksheet. And you do have the answers, if you notice that. If you look at the very bottom, the answers are there upside down. I encourage you to check and look. Okay, I encourage you to check and look. Alright. Good. Any questions? Okay. Perfect. Get started. I'll be calling you up to check your check my mark emails, okay? Satna 10 at Hotmail.com. Good. Sunny. Basra P. Do you have your own personal email?
No, that's